Okay, so just finishing up with the solutions. All right, so when they say alkyne series, they just mean anything that any straight chain alkane that would have a triple bond located within it. All right, so that would technically make it an alkyne. All right, so I've written down the formulas for these, all of these right here, and you can see that they would follow the general formula represented by this one right here. So CnH2n-2. Right? Moving on, which could exist as cis-trans isomers. All right, so there's two situations where you can have cis-trans isomers. One is the geometry around double bonds, all right, but the other is going to be the geometry whenever you have a ring. All right, so cis is when the substituents are on the same side of the ring. Trans is when the substituents would be on opposite sides of the ring. All right, so with the double bond, it's when if both groups are on the same side of the double bond, it's cis, opposite sides it's trans. All right, so this one guy right here can't be cis-trans because you have to have a substituent on each of the carbons. And this guy right here, you've got two hydrogens, so that can't have cis-trans. All right, if it had been something like this, where you have like instead of two hydrogens, you have one hydrogen and one methyl group, like this right here, you could have cis-trans. All right, so the only situation here where you could have that would be this guy right here. All right, and so if these two methyl groups are on the same side of the ring, like if they're both coming out towards you, that would be cis, but if they're on opposite sides, that would be trans. So what's the name of this? Okay, so we're going to find the longest group, or longest carbon chain, 1, 2, 3, 4. All right, so that makes this a this is going to be some sort of butene. All right, so so that limits it to these guys right here, and we've got, this is a situation where we're going to have E or Z. All right, and that's because on one of these carbons you've got two substituents. All right, so remember, for EZ you have to have one substituent and one hydrogen on each. All right, so we're going to rate these. The bromine has got a higher mass than the chlorine. This carbon has got a higher mass than the hydrogen, so that's your high priority, that's your low priority. And you can see that the high priority groups are on the same side, so again, this is the same side, so that makes that B. All right, for 23, how many pairs of optical isomers? Well, there's chiral center right there, there's one right there, and you can have these, if we just focus on this part of the molecule right here, you could have both towards you, this one towards you that away, this one towards you that one, or sorry, this one away, this one towards you, or both away from you. That's a total of 4 combinations. All right, which molecule is chiral? This would be the structure right here. That would be a chiral center right there. So that's A, which shows optical activity in the enantiomers. And 26, which contains a chiral carbon. All right, so if I take this molecule and I draw it as a structure, you can see this carbon right here contains 4 different groups. That makes that a chiral center. All right, so for this molecule right here, what kind of a functional group do we have? That would be an ether. All right, because that's an oxygen, and both of these are carbons right here, and neither of those carbons are carbonyl carbons. So that's an ether. All right, and I think I'm just going to skip this guy right now. That's an NMR question.